So, hi everyone, I'm Alessandra, and today I would like to discuss with you my work on population 3 stars during the Epoch of Reionization. I will start by showing you this plot that was already shown by Raffaella during her review talk, showing the POP3 cosmic star formation rate density evolution as a function of redshift. And as you can see, there are many different models and that are also on small and very resolved scales that show this late POP3 star formation, which is still occurring during the Epoch of Reionization. And this is allowed by the inhomogeneous nature of metal enrichment, which allows the persistence of these pristine pockets that can still form POP3 stars well after the onset of star formation at cosmic dawn. And so this doesn't work. I can use this one. Sure. So I confirmed this result in a full cosmological context by studying POP3 star formation in 8 cosmological simulations with the hydrocode Dusty Gadget. These are the largest simulations available that include a model for POP3 star formation, and they have also been shown to reproduce overall the star formation rate density and stellar mass density evolution and the main scaling relations, including the main sequence of star-forming galaxies. And moreover, they also allow us to resolve the star-forming environments of massive galaxies down to a stellar mass of about 10 to 7.5 solar masses. So in the simulations, I find that POP3 stars are found in galaxies all over the main sequence of star-forming galaxies, as you can see from the red dots in the main sequence plot here. And they are even found in massive and evolved galaxies that already host metal-enriched stellar populations. And so during the last year or so, I have been investigating more in details the detectability of these systems, focusing on looking for spectral features that can identify the presence of these stars in high redshift galaxies. And particularly, I have looked at the helium-2 recombination line at 1640 angstrom. So as Raffaella already mentioned, there are already a few candidates with tentative helium-2 emission that has been indicated to possibly be reconduced to population 3 stars. But so we might ask why we are not seeing even more of them. And so I have investigating 2 possible explanations for this. One is that we do not have a high enough sensitivity to be able to see them. In fact, we see that the helium-2 emissivity that we expect from POP3 hosting galaxies can vary a lot depending on the assumed POP3 model. And we need very deep observations to be able to see these systems, especially with some of the most pessimistic scenarios. In addition to that, I've also considered a possible alternative explanation. So maybe we are not able to see many of these POP3 systems because they fall outside of the field of view of our instrument. And in fact, in Dusty Gadget galaxies, these POP3 stars can be found up to 20 kiloparsec from the center of these galaxies. And so up to 90% of these systems can actually be missed, for example, in near-spec MOS when you point towards the center of Dusty Gadget galaxies. And I also wanted to add some thoughts on another probe that I have been investigating. So I have been investigating the possibility of looking for population 3 stars at the moment of their death as pair instability supernovae. These supernovae are very, very bright, and so they can be seen up to very high distances, which is, of course, interesting for us for looking for POP3 during the EOR. But they are also rare. And so here I'm showing some predictions for the number of pair instability supernovae that we expect from Dusty Gadget galaxies as a function of effective survey volume. And we see that, unfortunately, less than 1 pair instability supernova is expected in all the considered JWST surveys, while a better chance may be achieved with Roman. However, more optimistic estimates can be obtained if we also include all the unresolved low-mass galaxy populations up to cosmic dawn. And so I would like, as a concluding remark, I would just like to say that there are many challenges involved in the detection of population 3 stars. But I hope that during this brief talk I convinced you that looking for them during the Epoch of Reionization is not beyond hope, and there's certainly room for improvements, and so...
Thank you, Alessandra. And thank you again for all speakers of this early morning session, and another coffee session, and we come back in half an hour.